Okay, today the next part is about ellipses. So, an ellipse is defined as the set of all points in a plane such that the sum distance from one foci, so F1, to the point on the ellipse, and the distance from the second foci, F2, to the point on the ellipse is fixed. So they're saying, okay, this distance here, D1, and this distance here, D2, when you add those together, the sum, that no matter where I am on the outside of the circle, that distance should be the same. Okay, our foci are the two points inside the ellipse, F1, F2. Okay, the line segment connecting the two opposite ends of the ellipse, which also contains the center and the foci, is called the major axis. It's the one that's going to be where it's more elongated. So if you got something like this, it's going to have a major axis that's like similar to the x-axis, where if it looks like this, it's going to have a major axis similar to the y. Okay, and the points on the ellipse that lie on the major axes are called the vertices. Okay, whereas the line segment connecting the two opposite ends of the ellipse, which also contain the center but not are perpendicular to the major, we call that the minor axes. So it's the way that's not as elongated, and I usually call the endpoints of that minor axis the co-vertices. So let's just look at an ellipse and see if we can identify things. The center is the very middle, which is 0, 0 here. The major axis is where it's more elongated, which in this case is the y-axis. But the equation of that line is actually x equals 0. The minor axis is, in this case, the one that kind of goes perpendicular there, you can see it, the x-axis, but that line is y equals 0. The foci are inside the parabola. So in this case, it is 0.04 and 0, -4. The vertices, if you go just beyond the foci, they're at the endpoints there, which is 0, 5 and 0, -5. The co-vertices are on the ends of the minor axes, which in this case is -3, 0 and 3, 0. The focal distance is something I've not defined yet, but it's the distance from the focus to the center. So this distance here is 4, and it should map to the other side. Hey, look, it's also 4 here. So the focal distance is, we're going to use the letter C to represent that, but it's going to be 4. I'm not going to write the equation just yet, but it's just good for us to recognize. We'll talk about the equations on the other page. Over here on the right, this is showing you where the equations are coming from. We're going to use this formula for C, and that's kind of the picture that explains it. With this not being in person, I'm not going to confuse you. I'm going to say, hey, trust the formulas, and if you want to ask me about it, I would be happy to show you. So here we have one formula. It is x minus h squared all over a squared plus y minus k squared over b squared equals 1. And the way that they have it on your formula sheet as well is that c equals the square root of a squared minus b squared, or c equals b squared minus a squared. The only reason why they flip-flop that is depending on if a squared or b squared is bigger, you're always going to do the larger denominator minus the smaller. Okay? Our center will always be at that hk, as was described, and then the length of the major axis is going to be twice just a. So notice our formula has a squared, but if we take the square root, it'll be twice the twice a, or 2b, depending on basically whatever one's larger. Larger. And the minor will be twice b or twice a, depending on the way kind of you look at it. Okay. The foci, vertices, co-vertices, if that helps you, go for it. And we'll either have wide or tall. Okay. I think it's easiest, let's just look at a picture and then let's kind of see where those formulas are coming from. So, in this case, x minus 3 and y plus 4 means the center is at a positive 3 and a -4. As you look underneath here, you've got a 60 and you've got a 25. In this case, it is the 25 that is larger, So with that in mind, we know that in the y direction, it's going to be taller. So this one's going to look like this. So the major axis is going to be a x equals equation. In this case, it's just x equals whatever this x value of the center is, so 3. The minor axis will go the other way, and it always goes to the center, so it's just the y value of the center, so y equals -4. That's kind of what it's showing you. Oh, I didn't have the equations out there. Okay, so now let's look at the vertices. Here what we're saying is if I plot the point 3, -4, that's where my center is. If we think about the vertices, let's look at the 16. So the square root of 16 is 4, and the square root of 25 is 5. Technically, these are plus or minus, which kind of helps. And let's think about why that may help in just a second. So here, since the 4 is underneath the 16, that means since the 4 is underneath the x, that means in the x direction, you're going to go to the right 4. 1, 2, 3, 4. And you're going to the left 4. 1, 2, 3, 4. Okay. Since the 25 is underneath the y, you're going to go up 5. 1, 2, 3, 4, 5. And you're going to go down 5. And those are the 4 points that make your ellipse. Okay. So when we think about which of these are kind of like your vertices versus co-vertices, the vertices are the one that's the longer. So in this case, we went longer in the y direction, the 5. So if I go up 5 from the center, this point up here at the top is 3, 1, and the point down here at the bottom is 3, -9. Okay? The co-vertices are going to be on the left and right side. So in this case, are at -1, -4, and at 8, -4. If it's easier for you to think about it, notice here, they're telling you that like these vertices, you're adding or subtracting it from your x's and your y's, that value. Okay, the focal distance is something that you need the equation for. So the focal distance equals c equals the square root of the larger denominator, which in this case is 25, minus the smaller one, which is 16. So we get the square root of 9, which is 3. So to find the foci, in this case you go along the major axis, so that's the y kind of direction. So we're going to go up 1, 2, 3. We're going to go down 1, 2, 3. This distance here they're saying is 3. And those are the 2 foci. So they're not actually part of the graph of the ellipse, but they are inside of it. So we get the 2 points. Now that you've graphed them, you can probably read them. 3, -1 is the one on the top, and the one on the bottom is 3, -7. Okay, let's do it again. So here, the center, we've got x plus 2 means -2, and y minus 3 means a +3. So -2, +3. I would look underneath the x has a 64. The square root of 64 is 8. So that means you're going to go 8 to the right, and you're going to go 8 to the left of that center. In this case, it is going to be longer, wider than it is taller, because the larger numbers underneath x. When you look at the square root of 36, you get 6. So that means you're going to go up 6 and down 6. And you've got the 4 points that make your ellipse. Okay, the major axis, then you can tell, is the one. In this case, since it's a y, it's longer. It's going to be a y equals, and then you look at the center, so y equals 3, the y value from the center. Minor axis is going to be the x equals, the x value from the center is -2. I find the easiest way to look at the graph, so your vertices now, if I read the points from the graph, are -10, 3, and 6, 3. Your co-vertices are the ones that are up and down. So we've got -2, comma 9, -2, comma -3. Okay. The focal distance, remember you take c equals the square root of the larger denominator, which is 64, minus the smaller one, which is 36. So we get the square root of 28. This one's not necessarily a nice number. You can break it down if you remember like this tree where like the factors are 7 and 4. Oops, that does not look like 7, 7 and 4. And then 4 can break down into 2 and 2, so you got a pair of 2, so 1, 2 comes out. And I've got a leftover of 7 inside the house still. In this case, you're going to have to write that. I mean, you can definitely approximate it if you wanted to think about it that way, like 2 square roots of 7 is equal to about 5, just over 5, 5.3. But we're saying, okay, hey, they're going to go like 5, 1, 2, 3, 4, 5 in a bit. So it's going to be like here, and then you go left 1, 2, 3, 4, 5 in a bit, right? So we're like there. Okay, so with that in mind, notice there, since we went along, we changed the x value. So start with your center, which is -2, and add 2 square roots of 7 to the x value. The y value of 3 has not changed. Start with your center at -2, and this time subtract the 2 square roots of 7, and your y value has not changed in the two foci. While it looks kind of nasty, that is correct. All right. On this next one, the thing that's tricky about this one is that it is not in the format that you are used to. So we gotta go ahead and complete the square. So let's get our x's and our y's together. 4x squared minus 8x plus y squared plus 4y. And I'm always going to move the constant to the other side. That's been the same for everything, so -4. This time we've got to complete the square twice, right? I've got to complete this square as well as that square. So what completes this first square? I am going to add, you know what makes this tricky? Is you look up front, there's a coefficient, right? That coefficient of 4 makes it a little bit hard to deal with, right? Because if I just add, like 8 divided by 2 is 4 squared, I get 16. But then 4 times 16, does that exactly complete the square? No, it won't. So here, we actually want to take out that coefficient. So we'd have x squared minus 2x. I think we've done that once before. And then let's think about what number we'd add just there. Plus y squared plus 4y. Figure out the number equals -4. So now when you take -2 divided by 2 squared, we get 1. But this time, if I add 1 to that side, it's really 1 times 4, so I'm going to add 4 to the other side. And then here, 4 divided by 2 is 2 squared is 4. So I also add another 4 to the other side. Okay, so I'd have 4 times x minus 1 squared plus y plus 2 squared equals 4. In this case, I don't know if you recognize, but the equation is always equal to 1. So I've got to divide by the coefficient. So I'm dividing by 4, but I've got to divide everything by that same number. So I'd have x minus 1 squared. I usually leave this over 1 still because I think it helps you see the patterns, but you don't have to, plus y plus 2 squared over 4 equals 1. Okay, now that it's in this format, we should be able to kind of do the next things like we have been on the other ones. So the center is at 1, -2. In this case, the bigger number is underneath the y, so it's going to be taller, right? So the major axis, if it's taller, is x equals 1. The minor axis would be y equals -2. And at this stage, like, I always start graphing. It's not to say that's what you have to do. But think about, okay, in the x direction, you're doing the square root of 1. So you're going right one and left one. And in the y direction, you're doing the square root of 4. So you're going up, square root of 4, sorry, is 2. So you're going up 2 and down 2. And this is your little ellipse right there. So your vertices are going that up 2, down 2 from the center. So you get the point 1, 0, and 1, negative 4. I'm going to go down to the co-vertices for a second here, because we already had those in our graph. Those were the 0, negative 2, and the 2, negative 2. Right, it was going that right one, left one. Okay, focal distance is c equals the larger denominator, which is 4, minus 1. So we get the square root of 3. In this case, I know the square root of 3 is not a super nice number, but think about going from the center along this major axis. We're going to go up and we're going to go down the square root of 3. So if we're going up and down, we're adding that to y. So we're doing 1 and then negative 2 plus the square root of 3. And then we're doing 1, negative 2 minus the square root of 3. Okay, let me get you started on this next one, and then I want to see if you guys can complete it. This is putting it in standard form. So we want to get our x squareds and y squareds together, right? Our x's and y's together. So I'm getting my x's and then my y's together. And I'm always going to move this 27 to the other side, so I get equals negative 27. Okay, we do want to figure out the number that's going to complete these squares. But remember in this case, the tricky part, sorry, that should have been 72y, is that we got this coefficient out front. So if we factor out the coefficient, I'd be left with x squared minus 6x, and we're going to find that number, plus, I'm going to factor in 18 from both these, we get y squared plus 4y. Figure out the number that completes it equals negative 27. Okay, in this case, let's figure out the number that completes it, right? So this first one, negative 6 divided by 2 is negative 3, but when you square it, you get a positive 9. Be careful, over here, you're going to be tempted just to add 9, but remember that's 9 times a 5. Okay, I'm going to leave it there. See if you can finish, figure out what number goes here, and make sure you write that number over here as well. But remember, you multiply that times 18. And when you finish, if you've done it correctly, you should be left with x minus 3 squared all over 18 plus y plus 2 squared all over 5 equals 1. Remember, we're going to have to divide by the coefficient such that we get whatever the answer, divide by whatever the answer is such that you get it equal to 1. Okay, so now let's look at these next ones. We're going to start writing some equations. So it says find the equation of an ellipse with vertices at 6, negative 2, and 0, negative 2. So these are the two vertices. Okay, with just that, and then it gives us a foci as well. Just with that information, notice from the two vertices, you can find the center. The center's got to be halfway between those two. So what's halfway between 0 and 6? Well, that's 3, comma negative 2 is the center. So that might help to start with, like, you've got x minus 3 squared plus y plus 2 squared. And in this case, you know the equation always equals 1. That's never going to change. So you just got to figure out a and b. But the next thing it tells you is it tells you the foci. So let's just think about one foci for a minute. So if this is the point 5, negative 2. That means this distance here, which is c, is equal to get from 3 to 5, 2. So remember that c equals the square root of b squared minus a squared. So larger denominator minus the smaller denominator. So in this case, c is 2. In this case, you know it, since I gave you the two vertices, that it's going to be longer, right? Wider. So that means in the x direction, think about this as your x direction, we're going 3. So you can think about that as 3 squared. That may help you underneath the x squared to 3 squared. This is going to be 9. minus a squared. Okay, so we get 2 equals the square root of 9 minus a squared. Keep solving for a, so square both sides. 4 equals 9 minus a squared. Let's subtract 9 on both sides. Negative 5 equals negative a squared. A squared equals a positive 5. And this one, you don't even necessarily need to solve for a, because I know that a 5 goes underneath there, and I'm all done. You do not have to worry about this eccentricity at all, so skip over that. It is not anything that you're doing. Okay, let's look at the next one. Find the equation of an ellipse that has a center at 6, 5. Okay, so this time it gives me the center. Like, you can start, you're like x minus 6 squared plus y minus 5 squared equals 1. Okay, so this is the center. It gives me the vertex is at 11, 5. Once again, as soon as you know that it's got to open like the long, it's got to be wide. So, right, this distance is 5. So in the x direction, you're going to do 5 squared. So you're going to put 25 underneath the x. Now, all we've got to figure out is b. But the only other thing they give you is this focus is at 9, 5. So c equals the square root of the larger denominator minus the smaller one. I always just write b squared minus a squared. It really doesn't matter what you call b and a, is my personal opinion. So now the distance here is 3. So c is equal to 3. I already had that this was 25, right? B squared, we already figured that out, is minus a squared. Square both sides. 9 equals 25 minus a squared. Subtract 25. Negative 16 equals negative a squared. A equals a positive 16. And you're done. Okay. It wouldn't be any fun if we didn't have some applications. So we've got a whispering gallery this time. So whispering gallery is 47.3 feet long. The distance from the center of the room to the foci is 20.3 feet. Find the equation that describes the shape of the room, and then how high is the room at the center. So I would just think about this. It's not like I would just draw the whole ellipse, even if in our gallery it's very likely we're probably just like talking about the top half, right? So the whole gallery, right, is 47.5. So the edge of this is 0.3 divided by 2. It's going to be half that length. So why don't I go ahead and write what that actual distance is. 47.3 divided by 2. We get this is 23.65. Okay, the only thing they tell you is this foci here is at 20.3. So in this case, I always make life easy, right? Put this center at 0, 0. So we're going to just have an x squared plus y squared equation equals 1. Okay, in this case, x is the longer direction, right? So if I take underneath the x, it's going to be the 23.65 squared. But I've got to figure out what's underneath y. So recall, just like we did in the other ones, you have c equals the square root of b squared minus a squared. C in this case is the distance of 20.3 equals the square root of 23.65 squared minus a squared. So 20.3 squared equals 23.65 squared minus a squared. Subtract, I'll do a little shortcut, a squared equals 23.65 squared minus 20.3 squared. So when you do that, you end up with a squared equals 147.233 if I round. So that's the equation, right? And if you wanted to find how high the ceiling is, right, the height here is simply the square root of that number we just got. So when I take the square root of that, I end up with 12.13. In this case, feet is the height. Okay, one last one. This time, rather than our arch being a parabola, we've got an elliptical arch. Okay, the arch has a height of 8 feet. So this is a height of 8. And it's got a span of 20. So remember that whole span of 20 means that this is half of that, so this is like 10. Find the equation for the ellipse and find it to use the height of the arch at a distance 4 feet from the center. So once again, make your life easy. Put it at 0, 0. So you got an x squared plus a y squared equals 1 always. In the x direction, we've gone a distance of 10. So underneath x, we're going to do 10 squared and we get 100. For y, how high did we go? We went 8. So 8 squared, we get 64. And then the thing it asks you is for find the height at a distance 4 feet from the center. So we're looking for y when x is 4. So we're going to plug in 4 for x. And you're solving for y. I like to give you a challenge every so often. I feel like since we're in college algebra, you should algebraically be able to do this. Maybe pause it and see what you can do on your own. So as you come back, the correct process here would be 16 equals over 100 plus y squared over 64 equals 1. I probably would subtract this 16 over 100 on both sides. So you get y squared over 64 equals 84 over 100. Whether you cross multiply or multiply both by 64, either way works. I sometimes think that it's a little neater to do that. You get y squared equals 53.76. Take the square root of both sides, and y equals 7.33